Let me show you how to use .NET Aspire to build a completely functional system almost from scratch. In this video, I'll demonstrate how you can build a URL shortener using .NET Aspire, where we're going to focus on some of the cool things that Aspire allows us to do. So this is our starting point. We have a .NET 9 Web API without any functionality inside. The only thing I added in advance is a database initializer background service, which is just going to create our database if it doesn't exist, and it's going to initialize two tables. One is going to be the shortened URLs table, which is going to contain the actual short code and the original URL that we are going to use for redirection. Another table is going to be URL visits, where we are going to track successful visits for a given short code, and we're going to track when it occurred, the user agent, and the referrer. So this is the boilerplate that I have. I also have a shortened URL record with the short code, which is also the primary key, the original URL, and the created at date and time. But what is a URL shortener? I actually wrote an entire blog post where you can take a look at how to build a URL shortener from scratch. In the blog post, I also discussed some of the finer details of building a URL shortener. Now, in this video, I actually want to focus more on the Aspire aspect of things rather than the nuances of the URL shortener system design. But essentially, we want to have two main functionalities. We want to be able to pass in a long URL, for example, the URL pointing to this very same blog post, and in exchange, our system should return this shortened code that we can use for sharing the long URL. The second functionality is when we access our system with the URL containing the short code, the system should redirect the user, preferably with a 302 status code, and redirect them to the original long URL. Now, our system is going to need data persistence, so we're going to use a database like Postgres, and we're also going to introduce a Redis cache, which you can see now, and this is going to help us when it comes to performance. So let's go back to our code and see how we can implement a system like this. So I'm going to start by stubbing out a URL shortening service class. So let me create this class. I'll make it internal and sealed. And then I'm going to define just 3 methods that I'm going to need to implement the required functionality. So the first one is going to be an async method returning a string value, and I'm going to call it shorten URL. The argument is going to be a long URL. We could also call it the original URL. So let's go ahead and create the body, and I'm going to throw a new not implemented exception because we will get back to this method later in the video. Now let's create another method that I'm going to need. This one is going to return a nullable string. I'm going to call it get original URL, and the argument is going to be the short code is going to be the result of the previous method. So the short code here will be returned by the shorten URL method here. And let's create another method just for testing purposes. It's going to return an enumerable of shortened URL. We already have this type, and I'm going to call this get all URLs. And I'm also going to throw a not implemented exception. And we're going to get back to the implementation in a bit. Now let's register this as a scope service. So I'll say builder services at scoped URL shortening service. All right. So now I can go ahead and create my API endpoints. And the first endpoint that I need is a post endpoint. I'm going to call it shorten. And the arguments are going to be the URL shortening service. And then I'm also going to accept a URL that we're going to shorten, and this is going to be my query parameter. So what do we need inside of our endpoint? Let's do some basic validation. We have the URI type in .NET, and we can call try create and specify the URL argument. You can also specify the URI kind. We are looking for absolute URIs that contain the complete route that we should short. And the out parameter I'm just going to discard because I don't need it. So if I'm not able to create this, I need to return some sort of result. So let's return a bad request, and let's say invalid URL format. Otherwise, if this succeeds, then we can obtain a short code by calling the URL shortening service. We want to call the shorten URL method, and we're going to pass in the argument. And then let's return results.ok, and let's return the shortcode. And actually, let's return it as an object. So I'm going to just create an anonymous type. Then we're going to need another endpoint. This is going to be a get endpoint, and the argument is going to be our shortcode. And this is actually going to be our redirection endpoint. So let's accept the shortcode as the query parameter. We're also going to need the URL shortening service. So let's accept that using method injection, and then I can implement my endpoints body. So what do we want to do here? Let's grab the shortcode by calling URL shortening service, get original URL, and we're going to pass in the shortcode value. Of course, the variable here shouldn't be called shortcode. We already have that. This is actually the original URL. So now if the original URL is null, I want to return a results not found response, not no content. And if the original URL is not null, then we want to return redirect. And I want to pass in the original URL as the target that we are going to redirect to. And then let's add another endpoint. This is just going to be for testing purposes. Let's say the route is URLs. It's going to be async. I just need the URL shortening service. And in the body of this endpoint, I can just return results.ok and await URL shortening service get all URLs. So we have our API surface for the URL shortener. Now all that's left to do is to actually implement some interesting things in the URL shortening service. And it's at this point that I'm going to add Aspire. Now there are a couple of ways you can approach this. You could go ahead and scaffold the Aspire project, but with recent Visual Studio versions, you can right-click your project and you can click Add, and then navigate to .NET Aspire Orchestrator support. So I'm going to introduce that, and this is going to scaffold 2 additional projects inside of my solution. I'm going to get a service defaults project that configures telemetry, health check, service discovery, resilience, and many other things. So we're going to get the good stuff out of the box. And there is also the app host project, which is what takes care of running our application. So you can see right now we are running the API right away because we scaffolded the API project. So now I want to install some Aspire packages, and you can right click on your Aspire project and say add .NET Aspire package. And let's go ahead and install Postgres because I will be needing that to persist my shortened URLs. And I'm also going to install Redis because I'm going to use that to introduce caching. So with these 2 Aspire packages installed, let's update our app host. So how do you add a resource with Aspire? So let's, for example, create our Postgres resource. I can say builder add Postgres, give my resource a name. I can configure a data volume if I need to persist my data between application starts. And let's also add a specific database, which I'm going to call URL Shortener. And this is going to give me back my resource that I can now use to add a reference to this resource from my API project. So I can say with reference Postgres, and this is going to create a connection string when the app host starts. It's going to allow me to reference my Postgres database. I can also say wait for and add the Postgres resource, and this is going to cause the API project to wait until our database resource is healthy and running. Now let's also do the same for Redis. I'm going to say Redis in a variable, builder add Redis, and let's just give it the name of Redis. This is all I need. I'm going to add a reference to the Redis resource from my API project, and I'm also going to wait for the Redis resource to start. Now this is all I need inside of my app host project. And I don't think we will be coming back to this for the remainder of the video. Now, how do we connect to the Aspire resources or the services that are being started by Aspire from the web API project? Well, there are also client-side .NET Aspire packages. And if I right click on the URL shortening API, there is add .NET Aspire package. And this is going to give you a different set of libraries that you can use inside of our .NET applications. So let's go ahead and install Aspire MPG SQL, because this is the simplest way how you can connect to a Postgres database. And when it comes to caching, I'm going to use Aspire Stack Exchange Redis distributed caching. This is going to allow me to use distributed cache and is going to be connected to my Redis resource. So how do we use these services? Well, all you have to do is call a couple of new extension methods that you will get, and one of those is add mpg SQL data source. And here you should specify the name of your resource. In our case, this is going to be the URL Shortener database. Now, we also have a new extension method for Redis called add Redis distributed cache. And here I can just specify Redis, and this is going to register a respective implementation of the distributed cache, as well as some OpenTelemetry good stuff that I'm going to show you when we actually run this. So what do we get with this? We now have an mpg SQL data source that we can use for our queries, and we also have an distributed cache implementation that we can use for caching. One more thing I'm going to install that's going to help our caching implementation is the HybridCache library, and because it's still in preview at the time of recording this video, I'm going to install the latest preview version. So let's go ahead and add the HybridCache services. I will say builder services add HybridCache, and because this is still an experimental API, I will have to add pragma comments to get rid of any compiler warnings. So now we have all the dependencies we need to implement our URL shortening service. So let's start by injecting the mpg SQL data source. I will call this service the data source, and then I'm not going to spend too much time on the implementation details. I'll be using Dapper to write my SQL queries, and I'm going to quickly add the implementation for the respective methods. So for get all URLs, I'm going to execute a select statement, fetching the shortcode original URL and create it at date and time. We'll use our data source to open a connection. Of course, we're going to add a using statement so that we close this connection when we leave the scope of this method. And I'm going to use Dapper's query async method to execute the SQL query and return a shortened URL. Now this is actually going to return an IEnumerable. You could also cast this to a list if you don't prefer returning IEnumerable. For the get original URL method, this is going to be our implementation. I'm just going to select the original URL column from the shortened URLs table, and I'll specify the shortcode inside of my where statement. Again, I'm going to open a database connection using our data source, execute the query by passing in the shortcode as the query parameters, and we're going to return the original URL, which could be a string or it could be a null value. We don't have caching implemented just yet. We're going to add that in a moment. Now let's focus on implementing the shorten URL method. I'm going to first add a helper method called generate shortcode, which is going to return a random string that is 7 characters long, and we're going to get this string from the alphabet containing the lowercase and uppercase characters and numbers going from 0 to 9. I'll use enumerable range to give me an enumerable that contains 7 elements, and then I'm going to randomly select an element from my alphabet by using random shared and getting a next value. This is going to give us a collection of characters. I'm going to call toArray and then initialize a new string based on these characters. So this is how we are going to generate a random shortcode. So now I'm ready to implement my shorten URL method, and essentially this is going to call our helper method, generate shortcode, to get back a shortcode that we're going to try to insert into the database. And what I want to do is to insert the shortcode together with the original URL so that I can later return the original URL for redirection. So again, the same thing, we're creating a database connection, executing this query, and returning the result, which is just the original shortcode. Now, if I jump into the database initializer for a moment, we just briefly mentioned this aspect at the start of the video, but the important thing here is that we have a unique constraint on the shortcode column. So this means that if we try to insert a duplicate value, we're going to get an exception, and we need to handle this exception in the shorten URL method. So let's add a try catch statement, and the specific exception that I want to handle is the Postgres exception. Now I'm also going to filter this with a when statement, and here I want to check that the SQL state is equal to Postgres error code's unique violation. And this is a specific error code that only happens when you run into a unique constraint violation. Now, inside of the catch statement, I'm going to add a bit of logging, but essentially I want to define a max number of retries, let's say 3, which is how many attempts we have to generate a shortened URL. So I'm going to run this in a for loop. Let's say that the upper limit is max retries, and let's rename this variable to attempt. Next, I'm going to add an ilogger as another service, and I'm going to add some log statements inside of the catch block. So if we run into the max retries, we're going to log an error that we have failed to generate a shortened URL, and I'm going to throw an invalid operation exception. Otherwise, we're just going to log a warning that we had a collision, and we're going to note that we are retrying. Now, what happens if we get past the for loop? Well, in that case, I'm going to throw an invalid operation exception because we failed to generate a unique shortcode. And this completes our implementation of the shorten URL method. Now let's go ahead and introduce caching. So I'm going to use the HybridCache service for this. So let's go ahead and inject that. And the first thing we could do is to cache the original URL as soon as we manage to insert it into the database, which is going to be right here. So I can say await HybridCache set async, and my cache key is just going to be the shortcode value that I generated, and the value that I'm caching is just going to be the original URL. Now, what is the reasoning behind this? So there is a high likelihood that as soon as we create a shortened URL, we will need to redirect it. So we are preemptively caching this value so that it's available for our get method to prevent an additional query to the database. Now let's go ahead and actually use it in this method here. So we want to wrap this with HybridCache. So let's go ahead and do that. HybridCache has a getOrCreate async method, and we can use the shortcode as the cache key. Now the delegate is an async method, giving us a cancellation token. And inside of it, I'm just going to paste in what we already had. And let's, for example, just pass the token as an argument here. Now, what we're going to get back is the original URL. And let's go ahead and return that from this method. And there you have it. Now we also have caching support. So let's actually start the application at this point and confirm that everything is working as expected. You can see the Aspire dashboard here, and our service is slowly starting up. So Redis is now available and running. Here is our Postgres container, and then our API service. If I go into the details for the URL shortening API, you can see the two connection strings for Redis and the URL Shortener database. This is all configured by Aspire. Now, if I navigate to this address and Swagger, I'll be greeted by the Swagger UI, which isn't actually available out of the box in .NET 9. You will have to install the NuGet package yourself and configure it to target the OpenAPI file. So what do we have here? We have our shorten endpoint where I can pass in a long URL, for example, this one. It's pointing to an interesting article that I wrote a couple of weeks ago. So let's execute this endpoint. And we land on the breakpoint inside of the URL shortening service. So we're going to attempt to generate a shortcode. We managed to do this. This is the shortcode that I generated. And then let's open a database connection and try to insert this into the database. And you can see that this completes. Now we're going to preemptively set this value in the cache. And this is going to make it available for our get method in both the level 1, which is memory cache, and the level 2 cache, which is Redis. So let's go ahead and hit continue. And back in our UI, I'm going to get the shortcode that I can now use to redirect to the original URL. Now, if I send a GET request with the shortcode, I'm going to hit this breakpoint in the getOriginalURL method, and you will see that if I place a breakpoint here and hit continue, we won't land on the breakpoint in the factory function. And this is because we already cached the original URL. So if I hit continue, we're going to get an error inside of Swagger because it isn't really able to redirect us from the Swagger UI, right? This is expected. But if I navigate to this URL and I hit enter in the browser, we're going to hit this breakpoint again. So I'll hit continue. But when we get back to the browser, we're going to be redirected to the original URL. So this is my article, which is about the missing chapter of clean architecture. And I'm going to leave this as the pinned comment below this video. And I really recommend that you check out this article if you're interested about clean architecture and you want to see some alternative approaches to packaging the code inside of your applications. This was actually a bonus chapter of the original Clean Architecture book that I summarized as a hopefully interesting blog post, but you can let me know in the comments what you think about the missing chapter of Clean Architecture. Now, back to exploring .NET Aspire, I want to take a look at the distributed traces, and let's take a look at this trace here, which is the post request to the shorten endpoint, and you can see what's going on here. We have our API request, the insert statement that we are sending to our Postgres database, and then a couple of requests to Redis from HybridCache to preemptively cache the original URL. Now, the next request here is us requesting the shortcode, and you can see that this is just immediately returning the value. There are no database requests because we are able to serve this from in-memory because we have already cached it. We can also check out the structured logs. I really like the visibility that you get with OpenTelemetry and the Aspire dashboard. And with that in mind, let's explore another interesting aspect that you can do when it comes to OpenTelemetry metrics. I'm going to make a few additional updates to the URL shortening service, starting with configuring a meter, which is coming from the system diagnostics namespace. And the meter exposes a couple of APIs. For example, we can create some counters. And what am I counting here? I want to count the number of redirects and the number of failed redirects. You can give your counter a name and an optional description. You can even specify what is the actual unit that you are counting. And then I need a couple of more services to make all of this work. I'm going to inject the HTTP context accessor as another service. And then let's go to the getOriginalURL method. And here I'm going to first specify a small helper method that's going to grab the HTTP context, extract the user agent and the referrer, and insert this into the URL visits table for the specific shortcode. So this is just us opening a database connection and executing the query. Nothing too interesting here, but we're actually going to use this when we are returning the original URL. So regardless of if we return this from the database or the cache, we want to record a visit. So let's say if the original URL is null, then we want to count this as a failed redirect. So let's go ahead and add 1 to the counter. Otherwise, we want to track this visit or record it. So I'm going to call record visit, specify the shortcode, and I also want to increment the redirect counter by 1. Now the counter itself isn't all that interesting. So what you can do is specify some tags which can enrich the data inside of your counter. So let's say I specify a tag list and an individual tag. Let's call it the shortcode, and I'll actually specify the shortcode value as the tag that I want to be counting. And let's include this in the redirects counter. So how do we actually use these metrics and counters with OpenTelemetry? Well, we have to configure it as a data source. So first, I'm just going to add a small registration to the HTTP context accessor service so that we have it available. But when it comes to OpenTelemetry, we have to say builder services add OpenTelemetry, and then I can call the with metrics extension method, and this allows me to specify my custom metrics. So I'm going to say metrics add meter, and I'm going to specify the name of my meter, which is the URL Shortening API. So this is actually the name that I gave to the meter when we configured it in the URL shortening service. So now you will see how all of this falls in place. Let's start the application again, and let's again open up the Swagger UI. I'm going to fetch the list of available short URLs. So here is the one shortcode that I created in my database. And then let's execute the redirect action a couple of times. So I'm going to click execute a couple of times. Then I'm going to specify an invalid shortcode that I didn't create and execute this a couple more times. And then let's go back to the Aspire dashboard. And what I want to show you here is the metrics tab, where you can specify the URL shortening API. And if you scroll down, you should be able to see metrics from the URL shortening meter. And as you can see, we have two metrics here. We have URL shortener redirects, which tells us how many redirects we have counted inside of our service, which is currently 8. And you also see that we can filter this based on our tags. And the tags are the shortcode, and we just have one value. In the failed redirects, we also have how many redirects we failed, and the shortcode is just 1, 2, 3, 4, 5. So if I go ahead and execute this a couple more times with different shortcodes, we should see our metrics be updated in real time on the Aspire dashboard. So now you can filter the total number of failed redirects based on the shortcode. So in total, you can see we have 15 failed redirects. But if I filter this to just give me the failed redirects with 1 and 2, you can see that the total count is now updated to 2 failed redirects. And this is how you can use metrics from your .NET application and integrate this with an OpenTelemetry exporter. So this was a pretty quick demonstration of how .NET Aspire makes it easy to implement a fairly complex system in a short amount of time. If you want to grab the complete source code for this video, you can do that from my Patreon page. I'm going to leave the link in the description of this video. If you want to learn more about .NET Aspire, then I recommend that you watch this video next. Thanks a lot for watching, and until next time, stay awesome.